Hello everyone. So today let's solve the problem number 64, minimum path sum. Right. So let's see what the question states, Yaman. Yeah, just give me a second here. 1 second. Yeah. So we have been given an m into n grid of non-negative integers, right? So see here, so see this one is 3 into 3 grid. So we have been given m into n grid of non-negative integers. What we need to do here, we need to find the path from the top left. Top left in the sense we have to start with 0, 0 here, right? So this one is the top left basically. Yeah. So we have to start with the top left to the bottom right. So this one is the bottom right. We have to start with a top left to the bottom right that minimizes the sum of the numbers on the path. So we have to minimize the sum of the numbers on the path, right? So we may only move right or down. We may only move right or down, right? So we have to return the minimum possible. So see here, in this case, we can, they have already shown here in the within the orange basically 131. So this path actually will give us what is the sum actually 131 basically 5, 6 and 7. So this is one path, right? So this will give us 7. So next let's consider this one. Actually this path 1, 2, 2 plus 4 is nothing but 6. This path also, this one we can just go in this way, right? Down, down. We can either go down or we can either go left actually. Sorry, right actually. Yeah. And now one step, this one right, and then finally this path. Yeah. 1 plus 1, 2, 2 plus 4, 6, 6 plus 2, 8 here, and 9. So this path gives us 9 actually. Uh, there is one more path. So here we can just go here 1. This one we can consider basically 5. Then we can just consider 1 here and this one. So this one 1, 2 actually. 2 plus 5 is nothing but the 7, 8, 9. Again it gives us 9. And we can just consider in this way as well. So there are many paths, right? So you can just go on considering here. So one more path I'll show. The other paths you can just consider. So we can just go here. uh, we can just consider 3, and this path also we can consider, right? So 1 plus 3 is nothing but the 4, 4 plus 5 is nothing but 9, 10, 11, 12. So this will be 12. So this you can, you just have to, this one count for all the paths, right? So you can just see, in that way you can just consider all the path and you can just count the sum. So here the least that we get here is from this one. They have shown in the orange basically 1, 3, 1, 1, 1. So this way we can reach from the top left to the bottom right. So this one is the top list, the first one actually first cell, and the bottom right the last one, right? So here by this way we can reach the top left to the bottom right, which is having the least sum, right? Which is having the least sum. So this will be actually 7. 7 will be the least sum. So the output is 7 here. They have mentioned the same. Same goes with the next example as well. Or yeah, this example as well. You can just draw the this one grid. Actually, you can mention the cells and you can just see that. Yeah. So this is fine. Now, yeah. Now we are completely familiar with the question as well as they have given wonderful examples just for the sake of understanding, man. Yeah. Now let's do one thing. Let's discuss the approach followed by the complexities and then let's write the code. As usual, let's discuss the approach. First thing here, we will be going with the DP man. So we'll be solving this problem with a 2D DP. Yeah, just remember this one. We'll be going with the DP. So let's move on with the approach. The first step here would be, so let's define DP of ij. So we have to define, or we will be defining DP of ij. So as we are going with a 2D DP, so this is equivalent to the minimum sum to reach the cell I comma j. Minimum cell to minimum sum to reach the cell I comma j from 0 comma 0 from the start. This one. Yeah, this is the first step. That is the reason we'll be going with the DP of ij. Second step here, let's initialize the DP of 0, 0 to 1. Yeah, let's initialize the DP of 0, 0 to 1. So first row accumulates from left, nothing but DP of 0, 1, right? DP of 0, 1. First one accumulates the right. So it will be DP of this one 0, 0, 0, 1 actually. So this one, let me represent this one if you don't know. So this cell 0, 1, 0, 3. Initially, if you're starting this one Leetcode, right? So you might get confused. So this one is 1, 0, 1, 1, 1, 2. So this is 2, 0, 2, 1, 2, 2. Yeah, this is fine, I believe. So this one at the 0, 2, we have the value 3. Yeah, we have the value 3. So first row accumulates from left, actually from left to right we will be moving. 0 comma 0 will be 1 as I have represented. Next dp of 0 2, so this becomes actually 2. dp of 0 1 we have to go with, right? Sorry, dp of 0 1 will be 1 plus 3, 1 plus value 3, so this one plus this one, right? 1 plus 3, so this will give us 4. Next we have to consider this one 0 comma, so this one will be 0 comma 0, 0 comma 1 and 0 comma 2, man, sorry. Yeah, we'll be starting from the 0 comma 0, right? So next in the same row we have 0 comma 2 as well, so we will be going with dp of 0 2, and the value is 1 here, so this one will be 1 plus 3 plus 1, nothing but 5. 1 plus 3 1 plus this one, it will be 4 plus 1, previous one plus this one, the 1, nothing but the 5, right? So the first column accumulates from the top. We already have the 0 comma 0. For the first column we'll be going with a dp of 1 0. This one we have to consider dp of 1 0 1 and dp of 2 0, actually dp of 0 0 1 0 and 2 0, right? So dp of 1 0, what it will be, dp of 1 0 will be 1 plus 1, actually it will be 2, right? So dp of 1 0 will be 2, and the dp of 2 0 here, it will be the previous one plus 4, actually 2 plus 4, it would lead to 6. It would lead to 6. So here I can just write it as dp of 2 0, this one will be 6. First row and first column we have completed successfully. Yeah, first row and first column we have completed successfully. For the general cell, uh, let's take the min of top comma left plus current. For the general cell, let's take the min of top comma left plus current. Just remember this one example here. So we have went with a 4 basically. Let's consider for this one for the example, this one itself, right? So example, so we will be going with a dp of 1 1 equals min of dp of 0 comma 1. So for the general, this one, yeah, let's consider for this one. This is the general cell, actually, right? So this is not that we are considering from the first row or the first column. This is the general cell. What we will do, we will go with min of top comma left, min of top comma left, right? Plus along with the current, actually along with the current. Suppose we are considering 1 comma 1, right? Suppose if you are considering 1 comma 1, so this one will be min of dp of 0 1, min of top and left we are considering, right? Top min of 0 as well as min of 1, that is nothing but 4, actually min of dp of 0 1, right? So this one we have to consider 0 1, where it is 0 1, this one. So basically it will be 4, actually, right? So plus current also will be going with, so this will be 4, actually. Yeah, so this will be dp of 1 1 will be equivalent to the min of dp of 0 1, that is equivalent to the 4. Same goes with dp of 1 0, dp of 1 0, and this one dp of 1 2, dp of 2 1, and dp of 2 2, right? So dp of 2 2. Finally, you can just carry on with the same, this one, what do you call, formula here. This one min of top comma left plus current. So dp of 2 2, dp of 2 2 at the end will give us the value 7, will give us the value 7, actually. Yeah, if you apply the same thing, right? So the value that we got here is 7, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So this is the approach or the idea, dp idea. We have implemented the same thing for the exam on the example 1, actually, by considering the example 1, we can say. Yeah, now as we are completely familiar with the approach and the complexities, completely familiar with the approach, let's move on with the complexity. So what will be the time complexity here? The time complexity would be big of m into n, and the space complexity would lead to big of m into n as well. So the time complexity would lead to big of m into n because every cell is computed once. Every cell is computed once. The time complexity would lead to big of m into n because every cell is computed once here. So what will be the space complexity? The space complexity would lead to big of m into n as well, because storing a 2D DP table of the same size as grid takes big of m into n itself, right? Memory. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So now, first let's handle the trivial case one when grid is empty, right? Though constraints guarantee m comma n greater than or equal to 1. So what if grid is, um, it is equivalent to null here, or grid dot length here. So this one, if it is equivalent to the null, then let's return 0. This is fine. Yeah, now let's go with the number of rows and number of columns. So this one will be int m equals grid dot length. This is fine. And also let's go with the number of columns. So this one will be grid of 0 dot length. This is also fine. Yeah. Now let's do one thing. Let's go with the DP table to store the minimum sum. So let's initialize the DP first actually. Yeah, I'll just go with uh, DP equals new int of the same as this one grid, right? Size m into n. Yeah, this is fine, man. Easy. Now the base case we have to start this one cell value. So I can just write it in this way. We have already discussed this one. DP of 0, 0 is nothing but grid of initially we have to start with a 0, 0 itself. Yep. Now let's do one thing. Let's move on with the further things. First thing is we have to fill first row actually. Then we have to fill the first column. Then we'll fill the remaining columns with this one. What do we call that formula that we considered, right? If you remember, math.min of we'll be considering top and the left along with the current one. If you remember, nothing but in this case it will be current one will be grid of ij. So let's first let's articulate the same thing, exact same thing that we had discussed in the approach. First, let's fill the first row, right? First, let's fill the first row. I'll just go with for loop here. J equals 1, j less than n. Let me increment j here, right? So within this for loop, let me go with dp of 0, j. Let me assign this one to the dp of 0, j minus 1 less grid of, so this one has to be 0j. Yeah. So this is for the row. We are just filling the first row. This is fine. Now, now let's fill the first column. It can only come from top actually. So this one will be for int I equals 1, I less than actually m, I plus plus. So within the for loop, let's accumulate from the top. So this one will be dp of I, dp of I0, this one equivalent to dp of I minus 1. This is fine. 0. And also let me go with grid of I0. So this one will be grid of I0. This is fine. Let me come out of this one entirely. Now let's fill the remaining cells for each this one. Remaining cells, meaning each cell is current value plus min of top comma left accordingly with the approach that we had discussed. Right. So let's go with the for loops, two for loops, man. 2 DDP, right? So this one will be I equals, sorry, 1 second. Yeah. I less than rows as well as the columns for n equals 1, j less than n. Let me increment the j. So within the for loop, what we need to do, let's consider from top and from left, top and left, min of top and left itself we have to consider, right? So this one will be int from top actually, this is equivalent to dp of I minus 1 and j. This is fine. And also int from left actually, this will be equivalent to dp of I j minus 1. Yeah, this is fine, man. So this will be dp of ij equivalent to math dot min of this one. Let's consider from top. So this one is nothing but the top, and this one is this one left actually. Top and the left, minimum of top and left along with the current we have to consider. Current is nothing but in our case it is grid of ij. It's grid of ij. This is fine. Yeah. We are done with this part. Right. So now the final answer will be present in the last cell, right? Nothing but in well, if we have to articulate the same thing in the form of code, we can just write it as dp of m minus 1 n minus 1 for the last cell. Right. So I'll just give here return dp of m minus 1 and n minus 1. Yeah. So this is it for the code. Simple one. Let me format the code and let me hit the run button. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button now. So you can clearly see here all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases. Yeah. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.